All right, so this is the back side of the Quiz 2 review from Chapter 11, Part 1. So we're trying to solve this logarithmic equation. The issue is we don't have logs on both sides of the equation, right? So that means that we need to combine our logs together so we can create one log on this side. Since there's addition between them, that really means that we're supposed to multiply. So essentially what we're doing is we're doing x plus 4 times the quantity x plus 2 to figure out what goes inside of log base 2 on this side. So that means we need to actually multiply these by distributing. So we would get x squared plus 2x plus 4x plus 8. And then we need to combine our like terms. So we would have log base 2 of x squared plus 6x plus 8 on this side is equal to 3. Now that we've combined this all together, the issue is we have, oops, sorry, that's supposed to be a squared. Now that we have all this together, the issue is that we have variables inside of our log. In order to get variables out of the log, we need to change it to exponential. So remember, with exponential, we take the base to the answer equals what's inside of the log. So now the first step would be to actually cube this. So 2 to the third power is 8 equals x squared plus 6x plus 8. Now the issue is, how do I solve something like this? Well, normally we would try to get x alone, but the issue is we have an x squared term and we have an x term. So we can't just get x alone because there's two x's. So instead, we need to factor. And if we're going to factor, we need to have it equal 0 first. So in order to make this equal 0, we'd get rid of this 8 by subtracting 8 from both sides. So we would have 0 equals x squared plus 6x. Now, with this one, be careful, because remember, every time we factor, we're supposed to look for a GCF first. So in this case, my GCF is x, because there's an x term in both. So then that would be x times x is x squared. X times 6 would give me 6x is equal to 0. And then we can set each piece equal to 0 to get our answer. So x equals 0. X would equal negative 6. And then remember that we need to double check these for extraneous solutions. And the way we check for extraneous is to plug these into the original and making sure we don't get any negatives inside of our logs. So 0 plus 4 would be 4. That's positive. 0 plus 4 is 2, so I know this one works. Now when I plug negative 6 in, negative 6 plus 4 would be negative 2. That's not allowed, so then that is our extraneous solution. So our final answer is just C, which is 0. So make sure you're checking for extraneous solutions every single time, especially on the quiz. It's not just that it's negative, it's if when you plug it in, you get a negative number inside of the log. Then it's extraneous and it's not allowed. All right, next one is determine whether or not these are true or false statements. So let's look at letter A first. What I would do is I would take the one side that can be simplified, write it off to the side, and see if I can simplify it in some way. Now, a lot of times we'll want to go ahead and say, oh, 3 times 5 is 15, and say that this is true. The issue is the only time we multiply these is if there's addition on the outside. Only multiply if there's addition out or between the logs. So if this had said log of 3 plus log of 5, then yes, we multiply, because adding logs means multiplying. But if it's multiplication, there's really nothing we can do with it because there's not a rule for it. So you can't combine these, which means that this is false. The next one, again, this one only has the number on the inside, so I would pull 3 ln of 2 off to the side and try to simplify that. Well, remember, if there's this on the outside, that means it was originally an exponent. So this is really this is really ln of 2 to the third power. Well, 2 to the third power is 8, so ln of 8 equals ln of 8. So yes, this one is true. Then the last one we're going to look at is here. So if I look at this, I think subtraction is the one that I can normally simplify, and subtraction, remember, means to divide. So initially we might think this is right, but normally when we divide, don't we only divide the things that are in the log? So we would say this is log of x over y, which is different than how they have it here. So the division idea is good, but there shouldn't have been two logs here, which means that this is false, because it would have just been log of x over y. All right, number 7. So now we've got a whole bunch of logs happening on either side of this. So what our goal should be is whenever we see logs on both sides, and we notice they all have the same base, is we need to combine the logs on each side so that then we can cancel them out. So between here is addition, which really means we're multiplying. So we're doing x plus 1 times x plus 3 inside log base 3. So now we have to distribute out. So x times x is x squared plus 3x plus 1x plus 3. Then we would combine our like terms. So we'd have log base 3 of x squared plus 4x plus 3 on this side. On the other side, it's subtraction, so that means we're actually going to be dividing these. So that tells me that we're doing x cubed plus 5x squared divided by x. And what that really means is that I'm dividing each piece by x. So I can really view this as being x cubed over x plus 5x squared over x, right? Because we're basically distributing, but with division instead of multiplication. So then this would reduce to x squared, and this would reduce to plus 5x, and it's log base 3 of that. Okay, so now that there's only one log on each side, and these logs are the same, they're both log base 3, that means that we can go ahead and ignore those and just say, well, x squared plus 4x plus 3 equals x squared plus 5x. And now the goal is to get everything on one side so we can solve. So we would subtract our x squared, which means these would cancel on both sides. So then now when I look at this, we have 4x plus 3 equals 5x. Well, now there's only one type of x, so I don't have to worry about factoring because there's not an x squared and an x term, so I'm just going to move my 4x to the other side. So we have 3 equals x, and then that's your final answer. All right, last one. Solve this one. Well, in this case, when I look at this, right, there's only one log, and my variables are inside of the log, so I want to change it to exponential so I can get the variables outside of the log. So we would change this by doing 4 to the second power equals x squared minus 3x minus 2. So now we can actually simplify this, right? 4 squared is 16 equals x squared minus 3x minus 2. And now again, since we have an x squared term and an x term, we're going to have to solve by factoring. So we're factoring because there's an x squared and x term. So that tells me I have to get it equal to 0. Right? So if I get that equal to 0, the way to do that would be to subtract 16. So we'd have 0 squared, or 0 equals x squared minus 3x minus 18. And now we need to factor this. Well, we checked for a GCF first, and there is no GCF. So since it's a squared, we know that x times x would give me x squared, and because the first term is 1, I can just think about what multiplies to give me negative 18 and also adds to give me negative 3. Well, negative 6 times positive 3 would be negative 18, and they would add to negative 3. So now I can just set each piece equal to 0 to solve. So x equals 6, x equals negative 3. Now remember, you still have to check for extraneous solutions. A lot of times we want to think that negative 3 is going to be an extraneous solution because it's negative, but let's try plugging it in. So log base 4 of x squared minus 3x minus 2 is supposed to equal 2. Well, if I plug in negative 3 here, that would be negative 3 squared minus 3 times negative 3 minus 2. And this would be 9 plus 9 minus 2. 9 plus 9 is 18, minus 2 is 16. So we would end up with a positive number in there, right? So then I know that both of these actually work. So make sure that you are always going ahead and checking your answers, because sometimes the negatives will be extraneous and sometimes they won't. And in this case, like we said, we would have gotten log base 4 of 16 equals 2. And that's really true, right? Because 4 squared would give me 16. That's why negative 3 actually works, even though the x is negative, because it doesn't make the number in the log negative.